Okay, great. Okay, hi everyone. So, welcome to today's Creo 4 launch webcast. The goal of today is to provide everyone on the call here with a relatively comprehensive overview of the functionality and value that we can bring to our customers, both existing and new, with this very exciting release of Creo 4. Personally, I'd like to add that Creo 4 is the best CAD product in the market today, not just by the breadth and scalability, but also the depth of functionality that we have. So with that, let's jump onto the next slide. Jerry, if you can click through, please. Great. Okay, so let's look at today's agenda. Firstly, I'm going to be running through and introducing you to the presenters and the supporting team that we have on the call today. Followed by that, I'm going to be announcing our European workshops that we're running, hosting in the coming months. We're then going to go through the main 5 pillars of Creo 4, which will comprise of a combination of a value add slides and followed by demonstration. The webcast is planned to run for about 2.5 hours. We'll pause to take a couple of questions after each of the pillars that we run through, essentially we will stay on the call at the end for about 30 minutes or so if anyone has any significant questions that they would like to run through in any deep dive, etc., etc. As mentioned earlier, the webcast will be recorded and the slides will be made available to you also. So let's start off by introducing everybody. Jared, if we could jump onto the next slide, please. So I'll start with myself. I'm Chris. I'm the Sales Director for CAD in Europe. Joined PTC back in February 16. That was my second time. This is my second time. You can see I've got a strong background in CAD, worked for a number of other vendors with a majority of my time being spent at SolidWorks. I'm an engineer by trade, so I've had the pleasure of being a PTC customer when I first started my career. Please have a look at the contact details on the right. I'd very much welcome everyone on this call to add me onto LinkedIn. Let's move on to the next slide, please. So today we've got the pleasure of having some extremely knowledgeable CAD gurus, if you don't mind me calling you that, guys, presenting and supporting on the call today. So I'll start with Jerry Raver. Jerry is our Sales Enablement Director. He's based out of the US. Joining Jerry will be Phil Darlington. Phil's from our technical sales in the UK. And supporting the call as well will be Stefan Marks from our CAD segment and, of course, myself. So that's your team for the day. Let me jump onto the next slide. So before we go on to the main event, what I'm really excited to announce is that we're going to be running 3 workshops across Europe in March. Jerry and I will be running these workshops, and we're going to be having a real deep dive on not just the functionality, but really the value of Creo 4 and how to position and sell the product, as well as subscription, really to win new business and drive up revenue. So these are going to be full-day workshops hosted in Munich, Copenhagen, and Birmingham. They're open to all of our channel partners. Invites will be coming up soon. We do have limited space to approximately 20 attendees per session. So please register as soon as you receive the invite that we will be getting out to you shortly. Now, Jerry's run these workshops in the US already. We've had fantastic and very positive feedback, and there has been significant revenue generated by the attendees directly on the back of this training after adopting the positioning that they've learned. So I would strongly encourage all of you to try and attend one of these workshops. And again, you'll get the invitation shortly. So let's move on. And with that, what I'd like to do is actually pass over to Jerry, and we will start on the first pillar, which is going to be model-based enterprise. Thank you, and thank you, Jerry.
All right, thanks, Chris, and thanks, everyone, for joining. So what we're going to do today, myself and Phil are going to review those Creo 4 enablement themes, but we're going to do it in a slightly different way than what you've seen in the past through Webcast or even some of the decks. We've got more information that supports why customers are interested in the technology. So that's really the goal. We're going to talk about the themes, but we want to do it in a little different way. So we've all seen the themes, right? We've heard about what they do or what they provide at a high level, but we haven't really dug into what's the value to a customer? So let's start with model-based enterprise, which is also model-based definition, and the reality is it's 3D annotation. So it basically is a term that we use to describe this idea of having a 3D model that contains all of the information. So why do people need it, right? Why would a customer want model-based definition in our product? So to really understand the value, you need to understand the positioning of Creo MVD, and to do that, you need to understand that customers currently have these internal processes that are really based on this idea of having a complete 2D drawing. So what Creo MVD does is to really look at transforming those traditional 2D-centric processes and moving towards the idea of having this 3D model-based definition. So to explain and to really hit on the fact, there's a better way. We've got this 3D model. We've got all this great information captured in the model. So the question becomes, if I can give you a model, I can give you the geometry, the dimensions, the tolerances, the GD&T, the attributes, all the annotations. It's all contained in the model. So now you can visualize that information, you can access the information, and in addition to that, you can spin the geometry and interrogate it. Why would I go through all this additional effort to create or recreate a 2D drawing that essentially has the same information? So this is really the process change. If I give you this, why am I continuing to create this 2D drawing? Because it really is redundant effort if you think about it. I'm doing the same thing for 2D. So we've had the ability to add 3D annotations for years now, right? In every release of Creo, we continue to improve upon the creation of those annotations. What we've done with Creo 4 is to really extend these capabilities, and the way we've extended them is we're making it much easier for users to create their geometric dimensioning and tolerancing. So to explain that and to see the value or understand the value, again, why do we need it? Why do we need GD&T Advisor extension? So to understand that, you need to realize companies and users are really struggling to adopt and comply with these MVD standards. Why? Because standards always change. You have new principles, you've got new standards. So as a user, if I'm not up to speed on the latest standards, what I can be doing is creating the GD&T incorrectly. And because I'm creating it incorrectly and I don't necessarily know everything about it, what you have in most companies that are doing this, you have users that believe there are multiple ways to interpret GD&T. So rather than simply create it and move on, you have this big debate going on about what is the proper application. So what we're doing is losing a lot of productivity and efficiency because, again, users don't necessarily understand everything about it. So if they're creating GD&T incorrectly, another downfall is it's going to increase manufacturing cost. So if you use it correctly, what it will actually do is give manufacturing a larger tolerance to manufacture to. If it's applied incorrectly, you actually increase manufacturing because you're essentially over-constraining and over-tolerancing, which makes it harder and more costly to manufacture. So all of these things really add up to unnecessary expenses due to scrap, rework, change, confusion, and downtime. So the next thing to think about is, what does it give you, right? Why should I use GD&T Advisor? So if you think about what we've just discussed, people don't necessarily understand it. I don't necessarily know how to apply it correctly. So what this tool does is guide the user through the accurate and correct application of GD&T. So rather than me trying to figure out how to do it, I'm going to be led through the actual definition. So this tool is going to help me define it because it's teaching me what to do next. In addition to creating this geometry, what it's going to do is allow me to do it 4 times faster. So right now, we can do this with our 3D annotation capabilities. The authoring in GD&T Advisor extension is 4 times faster than traditional means. So in addition to creating it correct and faster, what it's going to do is allow me to restrict me from creating that invalid annotation. So as I select on a surface, for example, what the tool will do is show me what the applicable commands are. So if it doesn't make sense, those options are grayed out. So I'm creating it faster, I'm creating it valid. In addition to doing that, as I work, I have easy access to answers where I can review different GD&T concepts. I have integrated help. I have tooltips. I have quick reference materials. All these things help me not only learn the tool, but they help me learn proper GD&T practices. So the final benefit is that once I create all this great GD&T annotations on my models, I can actually repurpose it to support downstream processes such as tolerance analysis and even computer-aided inspection. So to finish, when properly defined, GD&T is good, right? It clearly communicates design intent, and it will decrease manufacturing cost. If you do it incorrectly, it causes a lot of problems. So now what we want to do is kind of move the ball over to Phil and let Phil narrate a couple of quick videos to explain how the tool actually works and let you see how the tool is actually utilized. So Phil, I don't know if you can take control or if you want me to just start playing.
Yeah, just start playing, and if I need to pause, I'll ask you to. Thanks.
Okay.
So this is a brief overview here to show you some of the new functionality that's available in just the general tolerancing functionality that's available in Creo. So this isn't the Sigmetric stuff. This is showing how we've improved the interface in just the standard Pro Engineer environment. Previously, you were restricted to whatever functions and commands were available in the drop-down menus. Now you can go and put anything in there that you want to, and it's totally customizable. This is the new Sigmetrics environment, and the difference here is it will only allow you to place the tolerances that are valid at that state. So what it was showing there is flatness and cylindricity. Now we can go and apply perpendicularity to this particular surface. And so what it's doing here is not only creating the tolerances, but it's validating what you can put on there, educating you so you understand that you're not allowed to have a zero tolerance, for example. And what it does when you place those tolerances, as you can see that it color codes them. Green means it's fully done, yellow is that it's not completed, and white means there's actually nothing on there whatsoever. So there was the flatness, as Jerry's just pointed to there. This is a very quick overview. Let's go and take a look now at something that's a little more in depth, and I have another video. Originally I was going to run these live for you, but they don't all come across perfectly running them live, so I've got a recording of the next video. So if we can jump to that then, Jerry, and have a look at this in a little more detail. And if I just pause this before starting out, one of the things it was a point I made to Jerry when we were talking about the content that we were going to put in here. I worked in industry prior to working at PTC, and I worked for a company that we did tools for the aerospace industry, and what we were making is ceramic cores that went into the turbine blades. If we had a situation where on the shop floor, if a tolerance was missing there, to then go and rework that through our company would typically take a day, because we'd have to take that drawing, bring it back into the drawing office, see which tolerance we'd missed off. We'd then have to go and get it signed off and approved by the likes of the inspection department, quality control, product development, also the tool room manager, and to go and find all of those guys running after them with a sheet of paper just to get it signed off could typically take a day. So to have something like this where you've got GD&T Advisor showing you that you've got everything covered is a huge saving for a business organization. And if any of you are working with customers that are manufacturing stuff, just thinking of people in the UK like GKN, Triumph, anybody like this, they need a tool like GD&T. So yes, if we could just move the video on then, please. Let's have a look at this now in more detail. So I'm going to start off here with a gripper model, and the first thing I'm going to do is show you how we've improved the functionality just in the standard Creo environment. So if we want to go and annotate the part, this is what you can do without GD&T, and it shows you how we've got and improved the interface and improved how we can go and place this information onto our part. So I go and place a geometric tolerance now, and I'm going to say that I want this bottom face to be flat, and this is the difference between Creo and the GD&T stuff from Sigmetrics. I could pick any geometric characteristic there. GD&T would only allow you to pick what was relevant. So I've said that I want this to have a flatness tolerance, and then I'm going to give it a datum tag of A. And the interesting thing here now is if I go and say that I want to place another geometric tolerance on this, and I want to do it with respect to a datum reference, and in this instance, let's say we pick A, if it already exists, that reference will appear as green. If it doesn't exist, then it will appear as red. So even in the standard stuff, it helps to guide you through some of the functionality that you need, or some of the work process that you need to go and apply your tolerances. So we're going to put on this instance that we want this hole to be perpendicular to that first surface, and we can go in, add in here additional symbols. This is something that we couldn't do before, sticking in all of this extra information. We were restricted to what was available in the menu structure. Now we can go and customize these as we see fit. So we're going to state what we want it to be relating to, and you can see then that in that menu box it actually came up green, and that's because we already have a tolerance tag that is created called A. So in addition now that we've created this perpendicular hole to that flat face at the bottom, I'm going to give it the reference tag B, and then I can go and compound these tolerances in additional geometry on the part. So let's go to an alternative view now and start to look at these holes on the base. One of the things I want you to note is that it's actually highlighting all 4 holes. So when we place this tolerance, it doesn't just understand that we're tolerancing the hole with the dimension on it. It understands this information semantically. So it's not just graphical, it's semantic. And what that means is it understands that that tolerance is applied to 4 holes. And I'm just going to put a note on there to say that it's applied to all 4 holes. And what's important here is if we go and then use this part in manufacturing or in CMM, then it will recognize that this tolerance isn't just on the 1 hole, it's on all 4 because it is semantically placed, not just graphically placed. Excuse me. So again, I can go and stick on some additional symbols, so for a maximum material condition, for example, or maximum condition. And these are the sort of things you couldn't do all of this customization previously in Creo 3. The ability to customize all of this information and make it exactly as you want it to be is something that's really quite powerful now in the world of GD&T in standard Creo. So there's just one more to put on now. I'm going to then copy that and put this onto these holes on the left and show how that I can go and pick the tolerance that I want, and I can go and modify the text on here. I can change what the tolerance is that I'm going to be using, and the additional text here, 4 surfaces, we don't need that. That was applicable to those 4 holes on the base. And really what I'm trying to get over here is the extent to which you can now customize the notes and everything else that goes onto the part. Previously, this was a bugbear of many of our customers because they said that they were restricted by whatever options were offered you in the drop-down menus. Now you can go and add anything you like. So again, I'm creating a dimension here, which is going to be an over-dimensioned dimension because the geometry has already been fully defined. So what I'm going to do is say that that's actually going to be a reference dim. So that's looking at the standard functionality available within Creo. What I'm showing here is we can now export this as AP242, and if I pick the annotations and rich content, anybody else that is reading AP242 will be able to get all this GD&T stuff into their system as well. So for example, if somebody is using a manufacturing system, a manufacturing tool, and they read that in using AP242, those tolerances are semantic and they will come across into their system also. Now we're opening up a new part, and this time we're using GD&T. So this is the Sigmetrics product. Notice the difference as we create tolerances. Look at the drop down. All we have is profile of surface and flatness. So we're going to put a tolerance onto this. It is in inches, so these values are quite small. So we're going to put a tolerance on here. We're going to give it a datum, make it a datum feature as well, and we're going to call that A. So what we've done to start off with is we've set up a starting point. We've said that the top of this part is going to be flat within a certain tolerance, and now we're going to start tolerancing other features with respect to that flat face on top there. So let's go and pick these holes, and what I'll do is I'll make them perpendicular to that flat face on the bottom. So there are two tolerances involved here. One is the tolerance of the hole itself. The other is the tolerance of perpendicularity with respect to that top face. So let's put the tolerance on the hole. So it's going to be plus and minus, and we can put those values on. As so. Accept that. So that's the tolerance for the hole. The next is the tolerance with respect to the angularity of that, or the perpendicularity, I should say, of that hole to the base there. So those are the two sets of tolerances that you can see. One for the hole, which is the perpendicularity, and one for the plus and minus on the actual diameter of the hole. And that's done, as you can see there, with respect to datum A. And you can see in the datum A in the menu bar there, that's actually green. I don't know how well that came across for you guys, but the reason it's green is because it's a valid reference to pick. If that reference didn't exist and I typed in A, it would actually be red. So now what I can do is place an additional tolerance on this now, and I'm going to say that I want my hole that's coming out to the side to be parallel with that flat top face. So again, let's put on the tolerances. We put on a tolerance for the size of the hole, and in addition to that, we then have a tolerance with respect to that flat surface. So there are a couple of tolerances involved here, and you can see what I'm tolerancing with respect to. I'm tolerancing with respect to the top face, A, and that's going to be parallel. So we want the hole to be parallel to that top face within a tolerance of 0.002. And we're going to give that a tolerance tag of C. So now we've got a datum label on there of C. What I can do is the holes that surround that major hole, I can put a geometric tolerance on those with respect to our datum target C. Let's do the other end before we start. Let's create an additional tolerance feature on here. A similar sort of thing. This is going to have a positional tolerance with respect to the hole at the other end, because obviously if this is going to be a hinged component, we want them to be in a straight line. So I'm going to say I want it to have a positional tolerance, give it the tolerance value for the size of the hole to start off with. Then give it a positional tolerance with respect to C on the other side. And there you can see we've got all of that tolerance stack up. So we know that C on the other side was with relation to A and B, and this hole on this side is also related to C, the previous hole that we had. So let's come back to the smaller holes now that surround the larger hole, and you can see how it picks up the entire pattern. So this is semantic. So I can do a positional tolerance here, and this is going to be with respect to C. So it is important to get across this idea of semantic. These aren't just graphical things that are there to look pretty. They actually relate to the underlying geometry. So if it goes into manufacturing, coordinate measuring machines, if we export using AP242, all of that tolerancing information will come across. Now, something I've done here is I've not actually put a tolerance on the hole. So let's see what happens. I put a tolerance on my geometrical positioning, but not actually on the size of the hole. So let's see what happens now. And you'll see that what it's doing here is it's advising me and it's educating and validating what I've actually done. And it says 0 tolerances aren't allowed. So go and add some tolerances. So let's go and do that. I'm going to make these plus and minus symmetric again. Let's put a tolerance on here. And that cross has now disappeared. So from that advisor tree, that warning has disappeared. So let's see how we're doing so far. I wonder how many of these surfaces are toleranced. And now what you see is everything in green is fully constrained or fully toleranced. If there's some things that were partially, they would be yellow, and anything that's gray is untoleranced. So what it's doing is you're creating the tolerances. It's helping you to validate and educate. If we just pause it there, please, Jerry. And then afterwards, so it's validating and educating, and then ultimately what you're able to do, as Jerry was saying, is this utilization, being able to semantically understand how they relate to the part and push them down into further downstream applications. So that's the GD&T section covered. On to the next one.
Okay,
so I think we're now going to look at productivity. Okay, yeah.
So I think what we're going to do now is open it up to any kind of questions. So if you have any questions about model-based definition and GD&T Advisor, this is where we'll take a handful of those questions. If we have a lot of them, we'll reserve those until the end. So Dana, I'm not able to see the QA because of my screen setup. So if you can validate any questions, that would be great.
Jerry, I looked at the question. This is Stefan here, Jerry. I looked over them. So there is one question from Tom de Kock asking if there is already training material available for GD&T, and I think he's referring to customer training material and customer.
I would say I'd have to look into it because I am not aware of anything at this point, but I can look into that, and when we have the recording ready for distribution, we can have that question answered with the email notice.
If I could just interject, I know Sigmetrics do have training material available, but it isn't official PTC training material. It obviously comes directly from Sigmetrics.
Okay.
Another question is, can the models of this GD&T demo be shared? Now, they are all from the new front demo, so I'm not sure how that normally rolls out, but traditionally all of the front demo material that we have gets shared with the partner field as well.
There was another question from Gerard Schwab. Within Sigmetrics, are there DIN libraries supported, and what about ISO libraries?
ISO, yes. DIN, I'm not sure. I would have to look at that. Because there's ANSI, ISO, ASME. I could just, if you just answer some of the others, I'll just have a quick look and see if I can find something on there.
Right. There is another question in the queue. Is there a price known for GD&T? Because no new price list has been released for Q2.
Hey, this is Stefan. There is a price. Yeah, there is a price available. Actually, it was already updated in Q1. So if you look at the subscription prices of Q1, you will find pricing in euro for all the new extensions that we have.
And that's kind of it for now. So I propose that any other questions that we take them in the end. I will take note of them.
All right, great. So what we'll do now is move on to the productivity improvements. So again, the important thing about all of these themes and really what we need to do with them is to make sure customers understand, number one, what do they mean and why do they need it? So one way to look at productivity is to really think about what allows you to be more productive. And this is where if you think about productivity, it really is about two things. It's about having usability and functionality. One without the other is not going to make you more productive. So for example, I can have a software that has all this great functionality, but if that software is not easy to use, a lot of that functionality goes unused. So it's not going to make me more productive. On the same level, I can have a software, and you can equate this to your SolidWorks or some of the mid-range vendors. If you have a software that claims to be, have higher usability, but it lacks functionality, again, is that going to make you more productive if you struggle to define the geometry the way you want? So again, when we're talking about productivity, when we're positioning Creo 4 and what we've done, it's important to point out to the customers This is what we do with, we started with Wildfire. Then we've got 4 releases of Creo, and what we've done is really look at usability and functionality and how do we drive productivity into the software. So to explain this, it helps to show the customer. Let's give you an example. So whenever we're talking about usability and functionality with Creo 4, we need to make sure they understand what we've done with the new full screen mode. So if you think about what we've done in the past, right, we had over on the left, you can see we have these menus, we've got our model tree on the side. So what happens is a user selects, and then he goes up to the menu tree, and he looks and he searches for commands, right? And this works, and we've got a nice clean menu. What we've done with the new full screen mode is we make it easy for users to simply go to full screen. So by selecting F11, you can totally get rid of all of those command ribbons, all of those menus. So as a user, I'm directly interacting with the geometry and the model. So now when I select on an entity, I select on a face, I have this nice little mini toolbar that shows me all the applicable commands that are relevant to my selection. So as a user, I no longer have to continually go up to the menus and look for that piece of functionality that I want to use. So the other great thing is what you've got is some customization. So maybe I'm doing a lot of, I want to create a surface finish, right? For whatever reason, that's what I want to do. I can customize that mini toolbar to where I can get easy access to surface finish. But again, what this does, eliminate menu travel, eliminate all of the searching for commands and options. So this isn't just PTC saying it's going to make you faster at getting your job done. We had 800 beta testers that utilize the software, and every one of those beta testers said that this functionality is going to allow them to get their job done faster. So in addition to full screen mode, what we've done with all the releases of Creo is a lot more in terms of usability and functionality. A great example would be the command consolidation. So if you think about, sheet metal design, for instance, now I go in and I select the option to create a wall. So in that one consolidated command or command dialog, I can create my wall, I can edit my sketch, I can add my bend relief, and do any number of things. So what this means to me as a user, I don't need to create multiple features as separate entities. I do it all within one simple dialog. So we've done this throughout Creo to take these commands and consolidate where and when it's possible. So for another example, I create an extrusion. In the past, I'd create the extrusion, then I'd go ahead and I'd create a draft. Now we have the option. I can do both those things in one feature. So the more we have these types of capabilities, the more we impact users on a daily basis. Simple things like picking on that face. Maybe I want to add some geometry to it. Maybe I want to just simply orient the model or zoom up to that component. All of these things help users every day. And that's important to point out because when we make user interface changes, this is where users spend the majority of their time, creating geometry. So I give you what seems like a simple thing, but if you're using that or doing that action multiple times a day, you're saving a lot of time and effort. So we don't stop with the UI, right? What we do is we take this same idea, usability and functionality, and we put it in throughout the package. So if you think about every release of Creo, what we've done is build usability and functionality into core Creo parametric. And again, this is important because we look at every place that users are using software, and it could be simple things like core modeling, it could be sheet metal, it could be freestyle, weld design, assembly design. This is where people are spending the bulk of their time. So product management works with customers, gets their input, and they drive new enhancements to make that more usable and provide additional functionality. So now we've got usability in terms of the interface. We've got increased usability in terms of core Creo. We take it one step further and we look at all of those added extensions. And then again, we drive the same level of usability and functionality in those extensions to make improvements. So if you're creating a lot of molds, let's make it easier to create a mold. If you do a lot of mold design and a lot of tool design, let's make improvements in those areas. The same thing with mold analysis, flexible modeling. It doesn't matter. We look at the products, we look at the extensions, listen to the customers, and then we make those usability and functionality enhancements that customers get access to when they upgrade to the latest releases. So as a final thing to demonstrate, this same concept, what do? We come out with new packages, right? So we listen to the customers, we understand where the industries are going, and we come out with new packages offering yet more functionality and usability. So what we've done with Creo in the cloud, if you think about productivity, what does your typical engineer do today if he needs to travel for work? If he doesn't have a local install of Creo, how is he going to get his job done? With Creo in the cloud, that user can simply go to a web browser, log in, and be running a session of Creo. The great thing is he can be using a machine that is not well equipped, and he's going to have great performance because we have Creo running on a high-end Amazon web service or web server, and all that's happening is those graphics are being relayed to the user. So again, a user who's on the road traveling for work or whatever reason, he can maintain productivity. We've looked at our rendering, right? If you go back even 2-3 years, it wasn't really easy to create a good high-quality rendering. Now what we've done over the years is continue to improve upon it. What we've done with Creo 4 is to partnership with Lexion Keyshot, and this tool makes it much easier to create very high-quality renderings and images. So again, simplify the process, make you more productive. GD&T Advisor, we just discussed. What is it doing? You're 4 times faster creating those annotations. Not only are you faster, but they're accurate, they're valid, right? It doesn't allow you to create invalid annotations. We're going to get to additive manufacturing later on in the deck, but what are we doing there for usability, functionality, and productivity? We're going to allow you to automatically create this complex lattice structure. Not only can you create it, but then you can go ahead and simulate it and optimize it based on, what are the constraints, what are the limitations, how do I make this as strong as possible, yet maybe think about how do I make it as light as possible as well. So great functionality, but again, customers need to realize when you're talking to them about upgrading to Creo, they need to know what are the benefits. Where is this going to make me more productive? How is it going to make me more productive? There are slide decks in Velocity that take all the way back to Creo 2. So I've got Creo 2, 3, and 4 slide decks that document high-level enhancements into each one of those releases. So the idea is when a customer says, yeah, but we're okay with Creo 1, I want you to show those slides. There's 150. We're not going to go through them all, and that's the point, to say, listen, here's the functionality we put in, and you're not giving this to your users. It doesn't make sense. So Phil, if you're up, we've got the demo coming up. You ready?
Yep. If you want to, oh, okay. Yes, we're going to go through this, and then I'm going to go through a demo afterwards. So let's first off then take a look at the new interaction paradigm. This has made a massive change to the way that you interact with the model. When we go and pick on something nowadays, in the old days, you may remember we started off with vertices, then we'd see the edges, then we'd see the faces, and all the time you were doing this query select sort of thing with your right mouse button. Now we don't have to do that. When you go and pick on something, you can go and work immediately. So when I select a part, I can go and zoom into it immediately. You can see when I pick a face here, immediately I'm into what can I do with that face? How can I interact with it? I don't have to go and pick it and then go and activate the part, go and do a whole load of stuff. I can immediately start to work with it. The box selection is far clearer here. You can see how I did a drag to the right. That enclosed everything that was inside the box, and I was able to hide that off. Look at this now. I select the end face of this component here, and immediately I say, I want to create a hole. Where do I want it? I want it to be coaxial. At no time have I gone up to the menu here. You can see I'm running in full screen. I then pick the edge. What can I do with that edge? Well, you can either chamfer it, put around on it, a little bit like a Creo Direct. It shows you what you're able to do directly there. And if I need to address the menu bar at the top, whenever I move the mouse up there, it will go and pop the menu down. I've hit F11 again now, so I have the menus back on screen. You can see here is the mini toolbar, and the mini toolbar always appears right next to the mouse, which is really cool. It doesn't stay in the last position you used it. It stays in the position right next to your mouse. So I picked on the end face there and gone and reoriented to screen. And that's just a very quick overview of the new interface. I'm going to show you some additional stuff now. I'm going to do some live stuff here. Few bits of functionality. I'll go through just a little bit of that mini toolbar again. If I start to show my screen, let's go to share. Let me make me the presenter. Jerry, can you just drag the ball up to me or make me presenter?
Let me go to pass keyboard and mouse. Let me find it here, Phil. Let me know if that works. Oh, no.
No. You see the little ball next to your name? Can you just drag that up to me? Or right mouse button on me to make you presenter.
Okay, hold on one sec, Phil. I'm going to stop sharing. Let's just do that, and you can grab it.
So I don't have a share my screen option available to me.
Okay, so now let me find you on the side here, make presenter.
That's the one.
Okay.
Yeah. Great, thank you.
You're welcome.
So hopefully you can see some stuff on my screen. The first thing I want to do is just show that mini toolbar again, because there was a question that came over, is the mini toolbar customizable? So I'm going to pick this component here. You can see the mini toolbar is right next to my mouse. That's really important because it keeps you really productive. The amount of mouse movement, you know, you're either going between minimum 10 mil, maximum 50 mil. That's all you're moving to get from here to there. If I want to customize this, right mouse button, and this is one of the questions, is it customizable? Yes, it is. You just go to customize, and what do I want to add into here? If I said something like, you know what, a command assembly, if I put in here datum feature symbol, so let's go and put that in. And there it is. It just appears on the mini toolbar. It's as easy as that. It's very, very simple to customize. So one of the things you noticed was the F11 functionality, or the full screen functionality. I'm just going to hit F11 here, and you can see that I'm now working in full screen. I get this message down here to tell me that I'm working in full screen. I have the option to not show it again. But the great thing is I have this massive amount of real estate that I can now work with. And if I want to access any of the functionality, when I move my mouse to the top menu bar drops down. If I move my mouse to the left, so the model tree, this is just not working totally correctly because of the presenting at the same time. But ordinarily, if you move to the left, the model tree will pop out. It's because I've actually got a little border from the webcast that's going on here. So you get direct access to the menus all the time. So let's hit F11 again. Maybe if I just move this over a little way, you'll see that working now. And just pull it in from the side here. There we go. So try F11 again. And no, it's not going to let me grab it. Anyway. Oh, beg your pardon, it wasn't even turned on. My fault. So F11, there it is. And the model tree pops out from the side. So one of the new pieces of functionality, and this was received really well. In the UK, we have a chap called Al Dean, and he writes the industry journal here in the UK, and it's a magazine called D3D. So Development 3D. And I showed him this piece of functionality that I'm now going to show you. And he thought this was an astonishing piece of functionality. He said nobody else in the industry has this, and it's for mirroring assemblies. So let's go and just put this into an end view. I've got a couple of map keys here to just rotate normal, and I'm going to pick up on this assembly here. So you probably saw before in the previous demo, if I drag a box to the right, it grabs everything inside it. If I drag a box from the left, you can see how it's a dotted box, and it takes everything that's crossing it. So you can see how it's grabbed everything there as well. But in this instance, what it is that I want to do is take the tracks on the port side. So it's using the naval term port and starboard. So I want to take the tracks on the port side, right mouse button, and say that I want to mirror this entire component about the center plane. So let's go and pick the plane. And the new piece of functionality that we have here, which is quite remarkable, is this perform symmetry analysis. So you imagine how many components are symmetrical. Cars, bikes, this robot, loads of things have symmetry on them. Now, ordinarily, if you had a car, and I've done a lot of work with car design in the past with the likes of Volkswagen, Audi, etc., you tend to design one part of the car. And then when you come to mirror it, what you end up with is you'll have wheel front, wheel back on the left, and then when you mirror it, you end up with wheel front right and wheel back right. You end up with 4 unique components, which is a bit crazy because in actuality, they are the same part. So what happens when we do a symmetry analysis during the mirror operation? It will look at all the parts and evaluate if, after they've been mirrored, the geometry would be the same. So let's go and have a look at the options. We can also evaluate quilts, datums, and curves to see if they're the same. And now I can go into the advanced option, and it will evaluate all of that track mechanism from the left and see what the result would be like after it's been mirrored. So here it comes up with this new window, and it tells us that, do you know what, I've seen this gearbox outer plate, and that can be reused because when it's mirrored over to the other side, the geometry will be identical. This bearing, that will be identical. Let's go and have a little preview of this now. Just go down to the glasses here, have a preview, and we can see what's going to be mirrored. And if I look at this, for example, the PD2 wheel, we can see the wheel on the left, we can see it on the right. It's been evaluated, and it understands that it's identical, and therefore it will actually get reused. So here is the wheel, that was the original on one side, here is the mirrored version on the other. And so all of these components are going to be reused. And if you think of the implication of what's happening here on a data management system, where you don't have duplicate objects, you don't have to have duplicate inventory because ordinarily you would carry spares. If you know that something is identical, that's a really powerful story, not just for data management, but also for inventory and spares control as well. So I'm going to accept that. And you'll see now that we have our assembly with our wheels on here. And if I go and look at this, this is the PD2 wheel side. And if I just go and do a search for that now up here, and then filter the model tree down to all of those components, you'll see that all of those wheels, well, I really just wanted to see the wheels. So all of these wheels have been duplicated from one side to the other, and they're the same components. Very powerful, very compelling piece of functionality. Next thing I want to show you, which isn't perhaps covered so clearly in the slide deck, is a lot of the functionalities surrounding industrial design applications. So something we did in Creo 4 was implement G3 connections. Now, for those of you who don't know, G3 is like the holy grail of doing A-class surfacing. So typically, what we had in the past, so if you look at a fillet is tangent, and you can actually see a hard edge from a fillet between something that's curved and something that's not curved. One step up from that is to have something that's called curvature continuous. And when we have something that's curvature continuous, you have a far better transition, but it's still not perfect. And people consider that a perfect transition is G3. That's when you have the same rate of change of surfaces from one side to the other. So I'm going to show you some G3. I'm going to show you some subdivisional modeling. And on top of that, look at some rendering as well. So I have a style feature on screen at the moment. I'm just going to make some additional geometry here. And you can see I've got one surface on the left. I'm going to create some additional curves now. Because it's industrial designers love working full screen. So let's hit the F11 button here and go and create some geometry. I'm just snapping to this curve. Let's snap to this one here. Middle mouse button repeats the last command, makes you very productive. So no going up to the menus. I've got my curves. Now what I want to do is create a surface. So let's move my mouse to the top. The menu drops down to reveal what I was hiding. Let's go and pick additional curves there. And I've gone and created a surface. And I'm going to accept that. And what I've got on the screen here is this is a curvature plot between the two surfaces. It's actually called a section plot. So let's go and pick up on my surface here, and if I do a right mouse button, you can see the new functionality. So I'm just using my zoom button here. So let's do that again. Let's zoom up on there. You can see I have G0 at the moment, which is simply positional. G1 is tangent. G2, which is what we always had, was curvature. We now have this new one, G3, which keeps the acceleration of the surfaces the same. So let's go and make that change and make this tangent. This is really cool in style because it says, do you know what? Your bounding curves are not tangent. Do you want me to automatically change them? Well, absolutely. Go and do the work for me. And there we go. And we've now got a tangent connection. And what this is showing me is that the porcupine for the surface on the left, so this porcupine here, is going in the same direction as the porcupine coming from the surface on the right. That gives us a tangent connection. Let's go to the next level of quality, which is G2. And what that will do is, well, before it does it, it says, do you want me to automatically update your curves for you? Well, yes, please, because it's doing the job for me. So it's now gone and made the porcupine the same length. So that means that we've now got one level higher polynomial, if you like, to define the curvature of this surface, but it's still not perfect. It's really good, but it's not what some, I use the word conservatively, but I think it's not what some Philistines in the industry tend to think of as A-class. Some people tend to think that you have to have G3. So now we've given it to you. If I go and pick on G3, do you want to update the curves? Yes, absolutely. And away it goes, and you can see that the connection now between one surface and the next is perfectly smooth. And this gives you a level of surface quality which is really unprecedented by PTC standards. And just to put this into context, it was probably a couple of years ago now that I did a workshop with the people from Richemont Group, which has products like Dunhill, Mont Blanc, Baum Mercer, all these luxury products. And I showed them ISDX, and we made the comparison to Alias. And the guys in the Richemont groups actually thought that our styling functionality was better than Alias. Now, I couldn't comment because I'm not an Alias user. They were the Alias experts, and they said it was better. So that's something to take on board. OK, so I've just hit escape there, taking it back to what it was. Hit the F11 button. So that's the new functionality we have for adding G3 connections to our surfaces there. The next thing I want to show you is the new stuff that we've got in Freestyle. Let's go and create a new part. And what we're now able to do is have multiple primitives. So previously, we've only allowed a single primitive. So I'm going to create one to start off here. Let's take this first primitive. Let's just go and move him up out of the way somewhere here. And maybe make a few changes. Let's just go and open this up a little bit. Let's take the whole lot and just move it over to one side. And then go and create another one. So we've got another primitive here. I'm going to just extend this a little way. Let's go and pick the top face. Maybe we want to go and extrude off of that. So let's go and move that up there, something like this. Maybe take the whole lot of here, move it over a little way. And then come up to maybe this face. Let's go and split the face a couple of times, move it backwards, and maybe take this face. And one of the things we can do now is, those of you who are technical and have used this sort of functionality, previously, if I wanted to have some extra control here, I'd pick this edge and say, do an edge split. But what that does is it splits the body all the way around so that I've now got these extra edges in here, and I don't necessarily want that. So let's undo that. What I can now do is say, just add an edge that goes from one side to the other. So I can go and create faces with, in the past, we could only have 4 edges. Now we can have any number of edges and entities going around our primitive. And now with the multiple bodies that I have here, I can just go and pick these 2 and say connect, and I can go and connect those 2 together. Something like this. And I was showing this to a guy the other week, they actually made beer pumps, and this is where I'm getting the idea from here. They actually made beer pumps, and I showed him this, and I spent about half an hour making a model for him, and he said, "Do you realize in that half an hour you've created something that took me a week to do using conventional surfacing?" So it's really impactful using this subdivisional modeling tool. So not only can we create, parts with multiple primitives, what we can also do now is we can go and import primitives that have already been created. So let's go and show you how that works. Create another new part, and let's stick in a freestyle feature. And the shape I'm going to use now isn't a closed primitive or an open primitive, a Creo primitive. It's going to be an imported primitive. So let's go and find something, and I've got a little frog, and you can see it's just an OBJ file, and you can find these for free all over the internet. I've just pulled this one down for free from a particular website. You can see somebody modeled the ground there as well. I don't really need the ground. So let's get rid of him, and what I can do is I can make this into a duck-billed froggypuss. Just pick up on the front of the frog there, pull him out, and I've just gone and made a change to something that I pulled from the internet. And this is really useful because a number of people have asked me, do I have to start every time with a basic primitive? Do I have to start with a sphere? Can't I have something else as a starting point? Well, now we've given you that functionality. Things are available on the internet. Go and pull them down, take advantage of them, and use them as a starting point for your own designs. Finally, I want to show you a bit of rendering. So let's shade with reflections, and there we go. The reflection seems to be okay there. Let's just now go into applications and go into photorealistic rendering. And you can see immediately the reflections we have on the floor here. And you can see this is very much like Keyshot. Well, it is Keyshot. You can see how it continually refines and refines the image until you get to a point where you think, well, that's acceptable, and then you go and screenshot it and save it off. How do we control the quality of this? Well, we have a drop down here, and in the real-time settings, we can see that I have the basic at the moment, and we've got some predefined lighting presets that we can go and select, or we can go and just add them ourselves, increase the number of bounces, and whatever else we want to do with that. And if I just pull this across here, what I want to show you is, let's go back to, I've popped the wrong window up, and let me just bring that back up here. And what I'm trying to show you here is we've got the number of cores being used here as 6 cores. And if you look at my processor, you can see 6 cores are being used. So an argument that's happened in the past is, well, is Creo multi-threading? More and more we are introducing multi-threading applications within Creo. And this is just an example of one of them where this will go and now multi-thread. And to show you just how good the rendering is, I'm going to close this off for a minute now and just create something very simple. And I'm just going to extrude a cube here. So let's use more of the right mouse button. Let's go and sketch something here, complete the sketch. Now, how well has it been or how easy has it been in the past to create a good rendering of a brick? It always looks very bricky. It always looks like it's very CAD generated. If we go and look at the photorealistic rendering now, you get all of this extra stuff that you're getting at the bottom of the part here. You can see all of the extra shadows that are being put down automatically between the base and the part. And if you think about the way it used to work, rendering in Creo, what you do is to try and simulate that. You'd actually lift the part up from the floor a little bit just to give you that extra dark shadow going along the edge there. Look at the corner as well. Look at how the light falls off around here. You get this extra lighting around the corner here, which is just so much more realistic than what we had in the past. So the real-time renderer, or the rendering environment that we get now from Keyshot, is a great enhancement on what we previously had. So that's really what I wanted to show you. I wanted to show you the enhanced functionality for productivity related to mirroring of assemblies, and also the industrial design type applications that we have available to us now. So that's being able to have multiple primitives, being able to import primitives, G3 connectivity, and the great new rendering engine using Keyshot. So back to you, please, Jerry.
Okay, let me, I think this would be a good time to start the questions while we do the switch over. So Phil, if you could, there we go, I think we got it.
Yeah, so I have a few questions here. In the mirror analysis tool, will it work on non-native geometry? Absolutely, because it's not looking at features, it's looking at geometry. So absolutely it will. Next one down, what is the file format for the freestyle? So that was an OBJ, or, well, I think Wavefront is the native product that originally creates OBJ. But anyway, file format for imported mesh is OBJ. Is the real-time renderer part of standard Creo? No, it is an extension. And those are the three questions I can see here. So, mirror analysis tool, yes, it will work on native, on non-native. File format, Wavefront. Real-time renderer, it's an extension. Because
Phil,
obviously we're licensing it from Keyshot.
Phil, I'm trying to take control. Can you maybe try to pass the ball over?
Yeah. There you go.
All right, so we've gone through the QA for productivity improvements. Again, any questions we don't get to right now, we're going to have time at the end. So, and another point we didn't make in the beginning I want to make is the fact that we're going to share all of this deck with you, so no need to be concerned about taking screenshots or anything else. We're going to give you the content that we're covering today. So next up, we want to talk about Creo to AR with ease. And again, following the same theme, what we need to think about is, you know, our customers are looking at it and listening to us saying, okay, we've got this AR capability. But the reality is that they're really looking at it and going, why do I need it? Why do I care? So what we need to do is to make sure, number one, we can educate the customer and let them know, because it's not their job to figure out why they need our technology and our solutions. So we need to do a better job. So let's think about why they need it. If you were to think about what companies are doing today, their processes are based on this whole idea of CAD-based visualization. If you want to share data, you want to collaborate, it really is about sharing and visualizing that CAD geometry. So what I want to show you is the fact that this is not the best process, right? It doesn't help you be more productive, and it really doesn't help you give data or provide accessibility to people. So I'll take you through this scenario. So let's say I'm a designer engineer. I'm working with Phil. So Phil and I need to collaborate and share some information. This is the process I need to go through today. I'm going to take my data. I'm going to go ahead, fire up Creo. I'm going to fire up and grab that assembly, whatever data I have to share. I'm going to take that information. I'm going to do a save as. So I'm going to save it to a file. Once I save it to a file, I'm going to go in, I'm going to take that file, and I'm going to zip it up. Then I'm going to figure out where do I want to put this content so Phil can get to it. Is it going to be Dropbox? Is it going to be Google Box? Is it going to be Project Link? I don't know, but I need to figure that out. Now I'm going to upload to whatever the location is. I'm going to make sure that my company is okay with it, because I don't know if it's secure enough. So there's a lot of hassle just to figure out how to get it. Once I get it there, then I'm going to go ahead and make sure I email or send him the proper invite so that he can get to the data. So imagine the amount of time that went into this. And maybe I don't trust Phil, right? Because he's a supplier, and maybe he's going to use my data and reuse it without my knowledge. So maybe I want to do one step more and say, I don't want to give him my native files. Maybe I'm going to step that data out first so he can't really repurpose it. So again, it's just even more time on my part. So what is Phil going to do? He's got to go through a similar process. Right? He needs to connect to whatever location. He needs to log in. He's got to download that data. He's going to unzip that data. Then he's got to hope that if I'm on Creo 4, he better be on Creo 4, because if he's on Creo 3, he can't use the data anyway. And now let's think about if Phil were not the expert he is, and he didn't know CAD, what is he going to do with that data? How does he open the data? How is he going to be able to open a CAD system? He doesn't know how. So if Phil is not a CAD user, now he's got to find an expert, find an engineer who can go through this stuff. So now when he gets it open, is Phil able to go in and interrogate and visualize that geometry? He really isn't. He's going to stand behind that engineer and say, hey, do me a favor, spin the model, zoom up, do these things. So it's not allowing Phil to interact and provide feedback. I'm not giving Phil the opportunity to get the details he needs, right? So am I getting the most out of Phil to leverage his expertise? Probably not. So again, the whole idea is what we're doing today, it's not the best, right? It doesn't allow, this doesn't improve productivity when we have to go through all this, right? People don't have accessibility, so is it really the best way to do it? And the simple fact of the matter is it's not. So let's think about what we just went through. Here's your traditional process, right? You're reliant on CAD knowledge, right? You're going to have to download this heavy data set. Then you need to, again, make sure that individual or person knows something about CAD to where he can actually use it. What if I were to transform this process? So rather than being reliant on CAD knowledge, let's just make it to where you're reliant on a web browser, right? Rather than download this big data set and unzip it, how about if you just need to install a mobile app? Rather than require you to know how to use the CAD and spin and do all this stuff, what if I just gave you some viewing options? So this is what we're talking about. This is process transformation, because now I open up this whole idea of allowing anybody to look at, access, visualize, and interrogate geometry. So if you want to communicate better, you want to collaborate better, what about giving people the tools they need? So this I can give to anybody. I can give it to my kids, my wife, my brothers, my sisters, my neighbors, and they can look at the geometry. So how important is that for a company? This is what they need to know, because again, they're saying, AR, great, but what does it do for me? So this is establishing what's in it for you, Mr. Customer. So what is it going to do? Again, transform and deliver business value, right? Rapidly bring digital products into the physical world. So it's not just about being able to look at it. The other great benefit is you're able to create this experience and allow people to interact and visualize with a sense of size, scale, and setting. So how important would it be if I'm a machine designer where I could design a machine and I could send it to my customer in an AR environment? That person could print that thing mark, go out to the shop floor, and now they could visualize the machine on the shop floor. Is it the location it should be? Does it make sense, or is it too big? Do we have proper access where we need access? So all these things, this is what you don't get visualizing on a laptop, on a computer. I don't know what scale. That could be, that motorcycle could be a toy. I have no idea. When you're looking full scale, it allows you to really understand what that product is. So the Creo to AR, it's going to transform the way engineers work, collaborate, and share information. And it's not just engineers. It's going to transform the way everybody's able to access and utilize that data. So we don't have a demonstration, but I just wanted to show you a couple of concepts. Again, here's, the machine example. Hey, I don't know. Do I have a machine? Will it fit in my garage? I have no idea, right? Here is an example of what you could do visualizing your products in a conference room in this collaborative environment. Again, you're not looking at the screen. You're looking at it and getting a real size of what this particular product is. So there's huge value, but again, our customers don't really realize that. So we need to educate them. We need to make sure they realize where and when AR would be applicable. So that's it for the AR. Phil, do you have anything to add? If not, we'll open it up for QA.
No, nothing to add. That's great. Apart from, I don't know if you mentioned MO10, that we should be able to have this direct publishing functionality where from Creo you can send it over to a server at PTC and it will come back to you with the AR information, so the Vuforia files, and a view mark that you can use to actually view those files.
Do we have any questions?
No, the only other question I see on here, oh, hang on, let me scroll down a little. What process is needed to get a product ready for a customer with AR? So I think I just covered that there. In MO10, there will be a direct one-hit solution from Creo where you can go and have this stuff published at corporate, and in return, and by return, I should say, you will get the Vuforia files and a view mark sent back to you. Yeah, and when is MO10 available? And that was the next question.
Let me just jump on your last response there. I had a lengthy conversation with Paul a week or so ago. So to explain a little bit further about what the Creo to AR with Ease is going to deliver, each user is going to get a thing mark that is capable of 5 experiences. What they'll be able to do when you pull up Creo, it's basically going to publish what you see on the screen. So if you have an exploded view, it's going to publish that exploded view. If you have the assembly, it's going to publish that. And again, you can have 5 experiences. In the first release, there won't be these tools that allow you to manage those experiences. If you want to add a 6th, you're going to overwrite an existing one. The idea is later on we'll have functionality, maybe it's a purchase piece of functionality that allows you to do more with it. Maybe it's animations and we start to do more things with it. But just to add a little bit more detail. Back to you, Phil.
Okay, other questions are, when is MO10 available? I'm not actually sure when it is at the moment. Jerry, do you have an update on that? Because originally I thought it was going to be mid-Feb. But I think it might be beginning of March.
I've got an email from Paul. When we get to the end in the QA, I'll go through my emails and I'll find it because I've got all the dates for the maintenance releases. So I'll make sure I remember to do that.
Okay. Are there screenshots available of the AR functions from within Creo? So I guess this is somebody who wants to actually just give a quick heads up to customers of what the actual environment and experience will look like when you interface with the AR functionality. Now, I haven't got anything, and I don't know, which is strange. I haven't actually seen anything. Like, I've seen the instrumented assembly stuff, but I haven't seen any of this. Do you have any screenshot, Jerry?
No, I have not seen anything.
No. Okay, so there's the answer for that. Will the AR part for viewing be free of charge? So these 5 publications that you're talking about, Jerry, are they free in the standard package, and then you have to pay for over and above the standard 5, or the free 5? Is that how it's going to work?
What's going to be is the initial release of AR is going to be free. So you have Creo, you're going to get these capabilities. What would be, and this is down the road, right? Once we release it, we give you the free stuff, which is everything I mentioned. You get a thing mark. You can publish 5 experiences. You're basically limited to publish what is on screen, free. Eventually, they'll have maybe some utilities to where you can manage those experiences. Maybe you can publish more than static models. So, for instance, we might want to publish an animation. Those would be future paid offerings, but the initial release is free.
Okay. Right, so that question about MO10 was the partner has a launch event on Feb 8th. I'm fairly confident that it will not be available by Feb 8th. How will AR affect Creo View? Well, it will sit side by side. It isn't as if Creo View will be replaced by the Vuforia solutions. It will just be an enhancement and an alternative way of being able to utilize your intellectual property. When will support for HoloLens be available? I haven't got an answer for that.
Me either.
No, I'm not sure. But you see, this is something I don't know if it needs to be uniquely supported, because I've seen Vuforia shown on HoloLens. I've seen Vuforia shown on iOS, and I've seen it shown on a Samsung Galaxy with one of these cardboard headsets. So I'm not sure if it is a unique export that you need to integrate with HoloLens. or whether it's just another solution that we port to. So because I've seen, so here's somebody else's question. On the Vuforia site, it says it's already supported for HoloLens. So there's your answer. So I've seen Vuforia on HoloLens. So I've seen it on iOS. I've seen it on Android. I've seen it on HoloLens. So if it's already available under the banner of Vuforia, it will also be available via Creo. Okay. So the last one, somebody's enhanced that answer from Tom saying, oh, and Gavin's thrown me up an answer here. We're working on getting HoloLens support for the Creo functionality, rather than the Creo functionality. Yeah, Creo functionality, and that will be available for the initial release as well. So there you go. That's from product management. So they're working on getting it done for HoloLens for initial release directly from Creo. Okay, so I think that's all. Those are all the questions that we have on the moment. At the moment. Next part of the presentation, we're up to design for connectivity.
So right, along those same lines of what we're talking about, why do we need it? Why do customers need it? This is where we're really looking at where people are at today, right? So you have this idea of a digital model, that's your CAD geometry, and then you have the physical model. But what there is there's no connection between the two. So that's what we're talking about when we talk about this design for connectivity. How do we make sure that the digital and the physical worlds can talk? So we're going to go through these slides, explain, you've seen these, but maybe go into a little bit more discussion about what they really mean. So in today's world, what you have is that companies spend a lot of time and effort. What do? They create this CAD geometry. So all of the time and effort that goes into making those models and all that geometry intelligent is great. But then we get to a certain point in time when the product is made and it's used in the field, and guess what? There's no more value to be gained from the digital model. So it's basically we put all this effort in, and now it just sits there, and we might recycle parts of it, but that's it. So companies realize they have this disconnect, and they realize there's a problem. So what a lot of companies are doing is saying, how do we address the issue? And they're addressing the issue by adding sensors to the physical product. So once you add sensors to the physical product, what it does is allow you to take that sensor data and connect back to the digital model. So this is really the concept of having the digital twin. So what is the digital twin? It's basically this one-to-one connection where I have physical data used in the field and I have the digital product that I'm looking at. So again, what it really comes down to is there's a one-to-one, right? The digital representation is getting information from a unique occurrence of the product in the field. And what it allows me to do as an engineer is because I have all the sensors data coming in, I get more insight into that product state, performance, behavior. So everything about it and everything I've censored allows me to understand how this product is being utilized. So the next question would be, what do I do with it, and why is that important? So to understand that, you can look at this one-to-one connection and go through a couple of scenarios as to where I would use it and why I would use it. So the first thing we'll talk about is performance-based analysis. So in this scenario, you have a prototype design, right? So we're maybe looking at the suspension. What happens is you create that suspension using assumptions, math, historical data, any information you have with the idea of creating the best part possible, right? Once that part is created, you take that geometry and you create a prototype. Now is where you're going to outfit that prototype with some sensors. So now I take my physical prototype and I put some sensors on it. Now we take that prototype and we put it on, in this case, the race vehicle, and we have somebody out there field testing it. So as this thing is being field tested, I'm getting real-time data and information about what is happening with the product. So imagine an engineer who utilized all the information he had to design the best part. But again, a lot of that information, it's historical data, it's some assumptions, maybe it's some math, but is it real-world information? He doesn't know. So if you were to take this connected strategy approach, now I'm able to take real-world information from field-tested products. I can compare that to what I utilized to design the part, and now we can utilize real-world information to make improvements and optimizations to the geometry. So again, I create this great digital model. I go ahead and I make a physical prototype. I put sensors on that prototype, and then I field test it, and I get real-world information back, and that allows me to make maybe refinements and optimize the suspension further. The next way you could utilize this is, let's say that part is being used, so it's in the field. I still have sensors on it, right? And what I want to do is make sure that as that part's being used in the field, if there is ever a condition where the product fails, I would like to be able to reproduce all that information, right? I want to know at the exact point of failure, what were those critical circumstances? Why did the product fail? So if I can replicate everything that was happening, now I have the information needed to define and identify the root cause. And if I can identify the root cause, now I know what changes I need to make to prevent any additional failures in the future. So again, what it comes down to is, let's get some real-world data, because assumptions, historical data, math, all these things are great, and they help us design to the best of our knowledge, but it's not real-world information. So both of these scenarios are really this one-to-one connection. That's kind of the important thing to remember. So the next use case is really expanding that, right? Why just go one-to-one? What if we have a one-to-many connection? So the example would be similar but slightly different, right? I've got a front loader. Again, how did I design it? With whatever information I had. It could be assumptions, historical data, math, you name it. I did the best job I could. So in this case, rather than just have sensors on one component, what I want to do is have sensors on a whole variety of equipment, so an entire product population is in the field, it's being utilized. So if I can use connected product strategies to take this information, bring it into ThingWorx, have ThingWorx analyze that data, and present the information back to me, what I'm able to do is to once again look at my assumptions and now apply real-world data and information to make improvements. So the example might be the fact that this lift front-end loader was designed to maybe lift 5 tons. What we might find out in all of this product population, none of these front-end loaders have lifted more than 2 tons, at which point I can look at real-world data, and now I can go back and reassess my design. Do I need to have this thing capable of lifting 5 tons if nobody's lifting more than 2? So maybe the part is over-designed. I may find out it's under-designed. Maybe I did the opposite and I only designed for a 2-ton, and yet people are going to 4 and 5 tons. But this real-world data allows me to take assumptions and replace it with reality, right? How is it being used? Because right now, that is the disconnect. I can think whatever I want to think, but do I have real-world data to support my design and development decisions? So the great thing is, coming about mid-year, we're going to have a new product extension. So what this product is called Product Insight Extension. What it will allow you to do is to provide the necessary connection between Creo and ThingWorx. And what that allows companies to do is to more easily integrate IoT into their design environment. So one way to think about Product Insight is it's really making this whole connected product idea, it's putting it on the critical path. So rather than doing and putting sensors on after the part's made, using Product Insight, now imagine engineers working with a connected products team. So early in the process, what they're doing is understanding what types of data you need. So now they know what types of data they're after. This is going to help the engineers identify what types of sensors and where they're going to be placed. Then they can also go ahead and look downstream and say, we're going to get this data from these sensors, but how do we configure the ThingWorx dashboards to where they're going to get the information, analyze the information, and give us the information back that we need. So by making this part of the design process, what you've done is make sure that companies have defined the data and the processes that are going to analyze, provide the information, so that when they get the information, they can support both performance-based analysis and data-driven design. So the example would be, and again, this was a conversation with Paul maybe a week and a half ago. You have companies like John Deere. They're applying sensors after the product is made. So they have a group of people that go out and they put a bunch of sensors on these products. But the reality is they never thought through what real data did they want to get. And then once they got the data, how were they going to utilize it? So what they have is just this overload of data that they really haven't thought through. This product brings connected product strategies to the forefront by saying, let's think it through from the beginning. Let's understand how we're going to get the data, how we're going to, where we're going to place the sensors, do we have enough sensors, and then how we're going to utilize that information for the purpose it was intended. So hopefully that cleared it up. We've got a demonstration, Phil, if you want to talk to this, and then we'll have some QA.
Okay, so I couldn't actually show you this because part of this recording that I made here, I did with a QA quality license that I had when we were doing the initial builds of Creo 4, and I've been told that I'm no longer eligible to get these licenses. So what I've done here is, to start off with, I've opened up an assembly, and what I've done is remove one part, which was just a blank end cap, and I'm replacing that now with a censored alternative. So this is a CAD equivalent of a physical sensor that exists in the real world. And you can see when that's been brought in, there's a note on that sensor as well. And you'll see that the note is not relating to anything. So what I'm going to do now is I'm going to pick a dimension from the model and relate that note to that particular dimension. And in this instance, what it is the note is now linked to the angle of the valve in the carburetor. So if I change the angle to 20 degrees here and hit regenerate, watch the middle butterfly valve turn around. And there you go, that's turned around to the angle that's being driven from this censored component. And this is something new for Creo 4. It's this concept of a censored assembly. And if you look at the model tree there, if you look at the throttle sensor component in the model tree, there's a new icon for it that's showing it to be a sensor. Okay, I'm creating a new part now called area, and I'm saying that I want this to be a censored component. So I tell it what the parameter is that I'm going to create, what the units are, and then saving off that part. If I come back to my assembly and assemble that in now, this is just an empty part, and this is a virtual sensor, because what I want to do here is measure the cross-sectional area of the venturi of the carburetor with respect to the angle of the valve. So what do I want to place into that particular virtual sensor? Well, I want to place the measurement of this. Can you see this blue feature here? That's the cross-sectional area that's left with respect to the angle of the valve. So I'm going to measure the cross-sectional area of that. So you can see I'm going to create a measurement and then save that off as a feature. And then what I'll do is I'll go back to my virtual sensor, which is the one I just created called area, and I'm going to change it now to be a virtual sensor that's going to read its value from that measurement analysis here. So let's go and pick the feature, the analysis feature with that measurement in, select the area, and insert that particular value. So that value for the area is now dependent upon the angle of the valve, which has been driven from the outside world. And if you just want to pause this for a second, Jerry, I just want to just say a few extra bits here. So if we consider what's happening in this situation, the cross-sectional area of the carburetor is not really something that can be measured physically. Sure, we could go and put a flow sensor in between the carburetor and the manifold, but that would change the characteristics of what's actually happening. It's not practicable in the real world to go and actually make that measurement of that cross-sectional area. but it is something that's very readily available in the world of CAD. So to take advantage of the information that's generated in the CAD world and combine that with the input that's coming from the physical world gives us a new level of information that we're able to extract from our intellectual property. And I'm going to talk you through a scenario here, and this is one that I was discussing with a friend of mine who's the CAD manager at GE Healthcare, and he told me about a scenario that happened with one of their beds. So GE Healthcare, I don't know if you know these guys, but they make, amongst other things, besides the tunnels, CT scanners, MRI scanners, they actually make these hospital beds. And they're quite expensive. They're probably $15,000, and one of these beds collapsed with somebody on it. So what happened from that scenario is the person sued the hospital sued GE. Why did the hospital sue GE? Because they take the bed as a PaaS, which is P-A-A-S, a product as a service. So they are actually leasing the uptime of that bed. And when it collapsed, it's not the responsibility of the hospital, it's the responsibility of GE. So I don't know what the value of that claim was, but I'm sure it would far have exceeded the cost of making that a censored assembly. Because what happened when they designed that bed is they will have looked at the joint on that bed, this scissor jack mechanism, knowing it would be the weak spot, and then they would have to have made some assumptions. And you saw this on the last of Jerry's slides, where you had assumption versus reality. So they will have made an assumption which would have been, well, how long is this going to get used each day? So let's say it's 10 times a day at 15 minutes a time. So therefore, that's going to be 2.5 hours a day, and the average weight is going to be 100 kilos. But in America, you know, people tend to be a little bit bigger. So let's say in reality, it was 150 kilos, and it was on there for double the time. So their fatigue analysis that was run when the product was initially designed was worthless because assumptions were made which didn't match reality. Now, if there had have been a load cell under the bed which recorded the weight and recorded the duration, that data stream could have been fed back to a Creo session, and what you could increment the input data for the fatigue analysis such that it reflected the real true life activity of what was happening with that bed. And as a result of that, you would have had a live analysis feedback that said, do you know what, we think it's time that you took the bed out of circulation. You could have had a big warning flashing light on the side of the bed that said, take the bed out of commission, it needs to be serviced. And this is something that we're looking at doing. We're looking at making Creo available as, and the term is a headless session. So it's a little bit like running Creo no graphics, but in reality what you can do is run it on a small processor that you could have stuck under the bed, and there could simply be an output on the side of the bed that will just highlight when the headless session of Creo that's running in this little discrete processor actually says, do you know what, you've hit a critical time now, take the bed out of commission, go and do some surfacing work on it. So that's a real life example of where IoT could have been a great benefit for GE, and indeed it's something that they are looking at. So if we want to carry on with the demo then, Jerry, we'll carry on and look at how this carburetor is now going to be used. So we've got this input coming from the outside world, which could have been the load cell, as I was just describing, coming from the GE bed. We could then go and do some calcs, which could be the fatigue analysis, or in this case, the cross-sectional area, and then feed that back out via to ThingWorks via the new product inside of Creo, which is, well, it's not inside of Creo, that links Creo to ThingWorks called, blimey. I've forgotten the name of it. It just eludes me at the moment. So what we're seeing here is we have a live feed connected to the angle coming in from the outside world. So this is a live feed coming from the sensor, and this is just an emulator that's running in the background here that just gives a whole bunch of values, and we can now attach that live feed to the input in ThingWorks and then feed that live feed into our Creo session and get the results back out. So that live feed's coming in now, and as I refresh the screen here, so basically I've just got to move it every time, you can see how the live feed value for the angle is continually updating. So we have 60 degrees there, and there is the area of the cross-sectional area of the created by the butterfly valve. And now if we look at the results coming back into ThingWorks, so we have the angle feeding out into Creo, and then coming back into ThingWorks are the measurements. I keep hitting the refresh button, and you'll see how those values update. It would be far easier to see if we actually had a graphical interface. Now, I'm not sure if the video is still running. So here is the graphical interface. We can go and make a mashup now that shows the values for the angle coming in from the sensor, and then the two measurements that I made in Creo being fed back out to ThingWorks. So in this instance, I've just got a couple of gauges that I've made, and they are going to update with the data stream that's going out. But in reality, this needn't be going just back to ThingWorks and creating a little graphical gauge here. This could be going out to a big light on the side of the bed that says stop or service me, whatever else. And so we've got the closed loop coming from the physical world, going to the world of CAD, and coming back out to the physical world again. So we have the valve angle going in, and this is changing. It's a little bit slow here. And then the areas and the clearance are updating. So I'm not sure if it's as slow for you guys as it is for me, but these things do update.
Oh. Phil, I think that was the end.
Oh, okay, right.
Yep.
Yeah. So Q&A for connected products. Could the headless Creo session analyzing the ThingWorks data be as a cloud-based service? Excellent question. I'm sure it's something that development are thinking about, and yes, that would make sense to actually have this running as a cloud-based service rather than having a local processor on board the bed. In a situation like we're talking about with Creo, where you've got a product that's $15,000, to go and have a headless session of Creo, which they're talking about making it quite cheap. What quite cheap is, I don't know. But sticking that inside a processor and then maybe spending $1,500 and adding 10% to the cost of the bed to have this analytics on there, it's probably something that's quite absorbable. But if it's something that's maybe it's going into a mouse, maybe it's going into something like that, obviously that's going to be too expensive and too big an overhead in that circumstance. So a cloud-based service would certainly make sense. So I'm sure that's something that we're looking at. Is there a connection with Simulate? Basically, anything that you can do inside of Creo and get results for can be connected to ThingWorks. So, yes, there's no reason why you can't use Simulate with ThingWorks, with this digital twin, or the instrumented assembly, as we're calling it. So the product I was trying to think of before was Insight. That's the new tool that's been developed to actually connect Creo to ThingWorks. It's the Insight product. Will sensor links be published to Vuforia in the future and sensor input be available in that environment? I don't know, is the answer to that. Stephanie, are we collecting all of these questions, and can we push these back to product management for anything that we are not able to answer at the moment?
You know, I'm taking notes, Phil, and we can review the webcast when we're done to make sure we have all of those questions documented and the answers.
Sure. One of the questions, just scrolling back up, is a general question. Can the slides from this webcast be shared, that are being shared with us, also be shown to customers?
I would say yes. If you look at a lot of the slides that you're looking at, we've already shared it at LiveWorks. We've shared the Creo 4 deck. It has been out in terms of so many different ways and avenues. people have seen it. I don't think there's anything in here that's confidential, and we couldn't.
Right. And hey, this is Stefan, Jerry, just to add, I think, most of the content that we are showing today is already available on Velocity. There are a few new slides that you have just recently produced, which is part of the session today. But other than that, I would say the majority of content is already there.
Yes. Do we have any further questions on design for connectivity, or are we all set?
That's it. Could the headless, yes, could that be in the cloud? Yeah, we're all set with that. All the questions are over. Yeah.
All right. So the final development theme is design for additive manufacturing. So let's follow the same suit and the same approach to what we're doing. Again, when we think about design for additive manufacturing, why do customers need it? We need to educate them on not only what the product does, but where they would use it and what value it provides. So one of the ways is to think about, what are you doing now? So we have additive manufacturing. You can call what we're doing today is subtractive manufacturing. Why? Because we start out with a block of steel and we machine it away, and what we're left with is the physical product or maybe a mold or something like that. But we remove material to get there. What additive manufacturing does is to start with nothing and add material and build up the parts. So that's what people are doing right now. So the challenges you have with the traditional approach is that as an engineer, you don't really have the freedom or the ability to be creative and innovative as much as you would like, because the majority of times what you need to realize when you're designing anything is that eventually we have to make it. So what you have is that a lot of those decisions that you need to make, they're actually driven by the manufacturing constraints and limitations. You also have to create additional geometry sometimes because you need to have that to support the manufacturing of the product. So an example would be adding draft to a molded part. But the reality is, as an engineer, I don't have the freedom. I have to make the part, right? So another example would be, think about it. I am designing a part, Phil's designing a part. You may have this great idea, but your design is too complex. So now your design complexity is really increased the amount of cost and really made it much harder to manufacture the product. And the reality is management is going to say, hey, that's a great idea, but we can't make it, right? It's too costly to produce the way you've designed it. So an example of that would be, think about the engineer who wants to make a strong part but yet make it lighter. So could I make a hollow part? I could. But then again, how do I manufacture it? Is it going to be a two-part construction? And if it's two-part construction, now how do I put the two parts together? Are they welded? Are they fastened? And again, it's one of those ideas that could be a great idea, but again, it costs too much to make it. So what engineers typically do is you might have a great idea, again, to make it lighter, make it hollow, but you just can't do it because the manufacturing costs are too high. So what ends up happening, we typically over-engineer products. We don't optimize them as much as we would like to because we know our manufacturing processes don't support making the product as cost-effectively as we would like. So along those same lines, think about maybe the inventor. Think about a smaller company who doesn't have, $20K, $100K to create production tooling. What do they, and even the large company who do have that amount of money, think about the ability for a company to offer many different product options. Why don't they do that today? Well, if they're not going to sell enough of it, they're never going to recoup their manufacturing cost. So that's kind of the trade-off to say, hey, this is a great idea to offer customized product, but after we go through everything to manufacture that part, we're never going to make our money back, so we're not going to offer that. So these limitations are why traditional manufacturing, it's maybe not the best. It's not the best for all avenues, right? A mass-produced part, sure, go ahead and do it. It makes sense to put all that tooling and all that engineering into making it to where you can mass-produce it. But what about all these other things that really, could we make a better engine if we didn't have to worry about manufacturing? Could we make a lot of different products? If we could think out of the box, we probably could. So this is really where additive manufacturing is going, right? There's an alternative to what we're doing today. if you look at additive manufacturing, it opens up a lot of new opportunities to look at innovation in a much different light, right? Think out of the box. Do something crazy, because you don't need to be constrained by this whole idea in the back of your head that says, yeah, great idea, but you can't make it. So additive manufacturing makes it possible to create geometry that, let's face it, in today's environment, it doesn't make sense because it's not cost effective, or we don't have the processes to manufacture it. So that hollow part example, right? This is that kind of pivot bracket from the Santa Cruz bike. So what do they do to lighten it up? They put some cuts through here and do some other things. The reality is, and this isn't just bike manufacturers, it's everybody, can I make it strong yet make it light? How would I do it? With additive manufacturing, I can say, I want to take this void, and rather than have a solid component, let me just fill that void with a lattice. So now I can remove a lot of material, yet I can use the lattice structure to make it strong. So again, just one example of saying, let's think out of the box, right? Let's do some things that allow us to get to those goals that we can't today. Why? Because we're limited by the manufacturing processes. So lattice creation, the optimization capabilities allow engineers to really think outside of the box, pursue creative solutions to problems, and innovate in a different light because they don't need to worry about the manufacturing limitations or constraints. So with that, Phil, we're going to jump into the demo again.
Oh, okay, fire away. So just to, I'll let you watch the video at the beginning here, and I'll just say about something else, because basically what I'm doing here is just starting off. This is that gripper component from the front demo data set that you saw me pick earlier when I was customizing the right RMB menus. And what I'm going to do here is I'm just going to remove the middle of this component and replace it with some alternative lattice structures. So basically, I'm just showing you all the different types of lattice structures that you can create. So I start off by creating a regular structure. Then I created this. This is a 3D lattice type. You can see up in the top left there of the screen, it says it's 3D. I can change the size of this, so that's just scaling it to 50%, or I can make it bigger, you know, and there we go, there's the lattice. I can then go and change that and change it from a square to a triangle. If I want to, I can take away the ball that's in the middle. I can change the way that it connects all of these things together, and then go and examine that and look at it again. I'm just going to continue now and look at some alternatives like 2.5D. And while I run through all the different options that we have here, I'm going to describe and I'm going to tell you about a situation that I found myself involved in a couple of years ago. There's a There we go. So, excuse me. So a couple of years ago, I was down at BAE Systems. They were looking at this shape morphing software, and they said, brilliant piece of software, it does some really crazy shapes, you know, fantastic stuff, but can't do anything with it because we can't manufacture it. We can't make a mold tool of it. So whilst it was interesting to them, they considered it a bit of a science experiment and didn't take it any further. I was in there just over 6 months ago, speaking to the same guy, and I was showing him this stuff, and I was showing him the solutions we have now for 3D printing. And we got full circle to the conversation that we'd had 2 years prior about this 3D shape optimization software. And he said, you know, Phil, that 3D shape optimization software 2 years ago didn't make any sense to us, couldn't do anything with it. Now, with 3D printing, it makes total sense. We can take these organic, really quite bizarre shapes, and we now have the ability to manufacture them. We can print in titanium, so it's not just about plastics and ABS and, you know, your cheap little desktop printers. They can print in titanium using the tools within our 3D printing software that we have here. They're able to look for proximity to other components, so analyze what the effect of one component will be on another. So if you have a really thick, heavy component that's going to cool slowly, compared to a smaller component that's next door that's going to or that's in close proximity that's going to cool very, very quickly, they're able to analyze that sort of information. And so yes, the tools that we now provide make absolute sense for these new products that are available, like this morphing software that will go and produce these organic shapes. Right, now what we're looking at is having gone and picked a particular lattice type that we want to analyze. What I've done is I've gone and selected a material now, and we're now going to look at doing an optimization. And so really what lattices are for are, if you're going to print something, if it's a mouse, for example, you don't want to print a solid lump of material that's going to sit under your hand. But what you do want to do is have something that's strong enough so when you put your hand on it, it's not going to break. So the skin of the mouse, you need to be able to support it. So that's really what lattices are for. But the other advantage is, because all of our lattices are true B-rep geometry, we're able to go and do so much more with them. We can actually treat them as true 3D geometry and go and run an analysis with respect to that lattice structure. So whilst the original point of having a lattice structure wasn't to use it as actual design geometry, it was there to be support geometry inside a 3D printed component, we found that there's so much more that we can do with this lattice structure, and being able to analyze it and being able to manufacture it is something that's really quite impressive. So we can see here now the deflection that we've got with that loading and a standard lattice that we've got and implemented here. And what we can do is now run an optimization. So let's go and look at the maximum stress that we're getting from here. And we can see that in this instance it's 4.83 basically. And what we can go and do is now go and we've got the displacement there of 0.131. We can go and optimize the mesh now such that we can strengthen this component. It will be suitable for the application that we want to run in, but when we go and print it, we're not going to be printing great chunks of pointless metal. We're only going to be printing what is actually needed to make this component function in its working environment. So we're going to change the maximum allowable stress here to be 2.1 instead of, I think we had 4.8 before. And maximum displacement, I noticed that was 0.013 before. So let's see if we can keep that equal to 0.124. So we're going to lower the displacement, and also we're looking to halve the amount of stress in the component. And how are we going to do that? Well, we're going to vary these parameters of our mesh, and we can say it can vary between the minimum 0.02 and maximum 0.05. And the diameter of the ball in the middle, 0.012 to 0.015. Its initial value is 0.13, so we're changing that by, again, roughly 15% there. And let's change the point at which we vary the mesh from being this heavyweight mesh down to the lightweight mesh on the other side of that dividing plane there. And then having got those variables in there and the parameters that we want to optimize with respect to, let's go and start the design optimization. So that's being completed. Let's look at the new design, and you can see that the mass of this component has been reduced from 0.2 to 0.188. Let's look at the stress in here now. We can see here is the maximum stress, and that's 1.88, down from 4.83, I think it was originally. So let's compare to the original. So that's the original one. And there you can see, originally it was 4.83, so that's less than a half the stress in that component. Of the optimized compared to the original. And finally, I think we can look at, deflection. Let's go and look at the displacement. And we can see the maximum displacement here. We said we wanted it to be 0.124, and you can see that that's optimized to 0.12409. And originally we had, I think, 0.131. So we've managed to achieve our goals. So we've reduced the deflection, we've less than half the stress, and we've optimized this product so that we can print it economically without filling all of that massive geometry in the middle. We've optimized it for printing, and we've optimized it so that it's going to also match its real world requirements when it actually gets put into production. I think we're back to the beginning again. So if you just want to stop it there for me, please, Jerry.
Okay.
Oh, yeah, well, that will do for that. And if you just pass me the screen, what I'm going to just show you is I'm going to show you some additional stuff here, which is not just the optimization, but it's also it shows you how we actually do the 3D printing. So for those of you who haven't seen this, I'm going to create another simple part. I'll just extrude a simple L bracket. And
Phil, you should have control now, Phil.
Okay. Beg your pardon, I thought it's share my screen. Right, I'm going to create a simple L bracket here. So let's just sketch some geometry. I don't want it to be very big. 50 by 20. And there's no solid geometry, so let's make it thin, and we'll make this 3 mil thick, something like that. Let's go and now do some 3D printing. And for those of you who haven't seen this, we have prepare for 3D printing or order 3D print. This is going to be something that's going to be available to you as a service through iMaterialize. If you say order 3D print, what will happen is it will look at the model, it will calculate how much it's going to cost, you will say place an order, it will go off to corporate, to iMaterialize, and it will come back to you with a bunch of options saying in ABS it will be this, if you want it done in steel, well, not steel, if you want it done in titanium, it will be this, and it will come back with a bunch of prices, and the idea is that you can place an order and this thing should be back to you within a week of having said print. So that's one thing, having the bureau service there. The other is to actually prepare it for 3D printing. And for those of you who haven't seen this before, printer, I have the PTC generic. This is the iMaterialize. And if you want to add a new printer, then it's very easy to set up a printer. You simply tell it what the volume is, what the material is that you're going to use, and away you go. What I want to show you now is some of the nesting stuff. So I'm going to pick up on this part here, and I'm going to say I want a bunch of these. I'm just going to accept that as done. So here are all these parts. That's not necessarily the most efficient, most effective way of nesting those parts in this tray. So what we're able to do is go and say auto position them. And that will make them, well, it will put them closer together based upon predetermined values that I have, which say proximity of one part to another. So that's bunched them all up together, which is very nice, but then we can do this nesting thing. And if we do the nesting, what it does is it goes and takes all of those parts, and this is like 3D Tetris, tries to fit them all together to find the optimal way of using the minimum amount of fluid or resin or whatever other material is in that tray, and that's what it's come up with. If I go and change the size of this, and go and change maybe the length, and you can see them all updating on the screen together. Okay, and then go and nest it again, you can see once again it's doing all the 3D Tetris bit, and it's optimizing how all of these components sit together, and it will stand them on end, side by side, doing whatever it needs to make the optimum configuration for minimizing the amount of material that's being used when we actually go ahead and print this stuff. So not only is it very clever, but demo this to customers, and it's very compelling to see this sort of demonstration where it's very graphical and shows the sorts of developments that have gone into the software to enable technology to perform what would otherwise be a very manual, tedious task. And it's something that you just couldn't do manually. So you can see how it goes and places all of these optimally. Good stuff. So that's the other thing I wanted to show you. I wanted to show how we not only have the optimization of the printing and the optimization of the lattice features, but we also have this optimization when it comes to laying out the components to be actually printed as well. And if I go back to just showing you here, printers. If I go to printer list here, you can see that I've got the printers here. If I want to add a new one, by default, we have a lot of the information, or nearly all the information for Stratasys and 3D systems. If I say this other, want to create other, next, give it a name. Obviously, we haven't got a model because we would if we had Stratasys or 3D systems, but the model, you know, we could go and tell it what we wanted to. But it understands also the technology that's being employed here, whether it's a polyjet, a fused deposition modeling head, whether it's a stereolithography head, what type of process it is that we're actually using there. And from that, you stick in the URL to your printer, and away you go. And that's all there is to setting up the printer. It's really quite straightforward. And whenever I've demonstrated this, it's proved very popular. That's all I really wanted to show. Let's go and have a look at the Q&A. So the questions, does the nesting take much longer on more complex parts? The number of faces on the part, in my experience as I've been playing with it, the time it takes to do the nesting is based upon the number of faces that are on the part. So if you have organic shapes, maybe it's something that's been made with freestyle, where you don't have many faces on that part, seem to do it quite quickly. If you have a complex casting which doesn't look, you know, significantly different to a freestyle part, but it has lots of faces because there are lots of like small surfaces created by fillets and drafts and that sort of thing, it does seem to take longer. So I think it's what it's doing is it's comparing a lot of the faces from one part to the adjacent part. So it does take longer. Does it take massively longer? No, it's still pretty quick. So that's the only question I had for nesting. Do we have any other questions?
Yeah, I think at this point, everybody, we could open it up to any questions on any of the topics. This is the end of the deck. So I guess if you have anything else you want to ask, we've got plenty of time. Phil, you want to just give me control so if in the recording we don't have a blank screen?
Yeah, beg your pardon. No, I'm just looking down the panelists here, and I'm seeing everybody with a red cross against them. Is that because they're all muted?
I would assume so, yes.
So, Dana, how do we unmute everybody to give everybody an opportunity to speak here?
If someone wants to ask a live question, just raise your hand and I will unmute your line.
Okay, thanks. So if anybody does have a question, if you can raise your hand on the participant panel. We can...
Phil, actually there is another one. Are we supporting all 3D printers, or is there a special list from PTC?
So initially we're supporting 3D systems and Stratasys. We will have all of, because we've developed a lot of this functionality in conjunction with those guys. So that will be it in the early days. Whether we will support more in the future, I don't know. But as you've seen when I was showing how to set up a printer, it's very straightforward. You need to tell it the URL for where it's actually residing. You need to tell it the material and the process that's going to be used. What actually comes from Stratasys and 3D systems is when you actually pick the machine that you're going to print on, what it does is a lot of the stuff that relates to support material and also proximity to other components, that information comes directly from the printer. So when you do that nesting, when I was doing the nesting manually, what it was doing is it was reading a config file to say what the minimum distance should be between one component and another, and that was set up in a config. When you actually go and define or pick a printer from the list from 3D Systems or Stratasys, all of that information relating to how close components should be for optimal printing comes directly from the printer, so you don't have to configure it manually. So that was a long answer. Short answer, 3D Systems and Stratasys. In the future, I'm sure we will add more. So the next, from Julian. Hello, Julian. Are the events in Europe for pre-sales and sales combined? And then the question is, are they technical events?
So the events coming up in Europe are basically taking some of the content you've seen today, but expand upon it, but it's more along the lines of positioning and getting the customer value established, educating the customer about what these capabilities are. Not a technical session, not about using the product as much as it is explaining why customers need these products and what value the products provide.
Thanks.
Mm-hmm.
Will there also be hands-on technical workshops like we had with Creo 3? That's coming from Tom DeCock.
I don't know of any. It will definitely not be part of the workshop content we have planned that you're seeing on screen. It's not to say something may not come in the future, but I don't know of any plans at this point.
Yeah, and I would echo that. So far, I'm not aware of any plan or any scheduled events for hands-on technical workshops.
Yeah, all of the content, we should make a point, all of the Creo 4.0 enablement content is in Velocity. You can access everything related to Creo 4, all of the decks, all of the content, all of the product management recordings. The information is there. That is your best avenue to get to Creo 4 enablement content.
Yeah, and I think this is very important to mention again that on Velocity actually there is all the recordings that the product managers did during the course of the summer where you can really, you know, whatever area of interest you have, you pick that one and then it's kind of roughly a 60-minute recording that is very technical, you know, done by the product managers. And I think, you know, that should give you the information that is needed.
There's a question that came through through chat. Is there support for Windows Print Manager in the future?
I don't know.
I'm just wondering what that's what the full question is there, because if I want to print from Creo at the moment, I use Windows Print Manager. So is this because you're thinking it might not work anymore, or is it because you're not able to get it working, or what's? Can you elaborate a little on that question, please? Questioner?
Yes, Martin, if you want to raise your hand, and I can unmute your line. He said specifically related to 3D printers. He doesn't have a mic, so.
Ah, right. Okay, I understand. Right. I don't know. I don't know. Yeah, I don't know with relation to 3D printers whether we'll use the Microsoft Print Manager.
And there's a question in the queue from Jens.
Yeah, Jens, I have the impression that Philip showed more videos than what is available in Velocity, and some of that was quite cool. Am I right? Yes, it was cool. And if so, will that also be available? So I think the videos are embedded in the presentation. Will you just give that out, Jerry, with the videos in them?
Correct. Yeah, we'll figure out.
Yeah.
I'll get together with Stefan. We'll figure out the best way to distribute it. But again, everything you've seen today, you'll have access to. All of those videos are embedded. What you're seeing today, and to that comment, you had the standard ones that you got out of the Creo 4 overview, and then there were some additional videos that Phil had created, and you're going to get access to everything.
I guess most likely that refers to the video that you showed for Design for Connectivity, Phil. I'm just not 100% sure if we're able to really release that.
Stefan, I'm with you on that. I'm not sure either. And the reason for saying that is because QA wouldn't give me a license for the instrumented assembly stuff for the Insight product, because it has changed so significantly from when the Stuttgart event took place.
Yeah, so actually product management is really a little cautious here to release too many information already now. Like the video that you guys have seen, and you're all kind of really eager to get hands on that. But since this is still working process, and it said like mid of this year, calendar year, it will be released. I'm a little worried to already promise that we are going to give you guys that video. I think that another person already wanted to have that for eventually an event or so. So we need to check that if that is really okay to share already now. Else you need to wait a little longer for that.
Yeah, that may be the one video that gets dropped from that full presentation pack, I have to be honest. Yeah. Final question. I guess this is for you, Jerry. Well, actually, I don't know if you're responsible for it. But the question is from Henrik. Hello, Henrik. When will the Creo showcase be updated with Creo 4 contents showing the new capabilities?
There's been a lot of debate around showcase, and I think the latest I heard is they're looking at continuing investment. But I'll check with the demo team, and I think it's marketing who jointly own that. There was a time where it was debated whether or not we continue to invest, but again, I'll get that answer.
Yeah, I think the showcase is a really good asset. So for me personally, it'd be great to see it in there. Yeah. And another one from Stefan Vlamnik. Apparently, Showcase doesn't work on Windows 10. I don't know. I've got Windows 7.
Yeah, and that is an ongoing debate that we already have with marketing. And I think it is the fund that is having that discussion. So no news on that side.
Henrik Solution says get an iPad. Yeah.
Do we have any more questions, Phil?
That's it. Nothing else.
Okay, guys, it's Chris here. If that's the end of the questions, I'd like to again just champion this set of workshops that we are running. We have got Jerry. We're bringing him over from the States to come to Europe. As you've seen today, he is a wealth of experience, and the material that you will see in that workshop is going to be different from the functionality material that you will have already seen or now had some access to. As Jerry highlighted, we are really going to be focusing on the value, how to position, how to sell, how to speak with people in order to be trustworthy and credible, and then identify opportunities and win business. So we're really driving down the sales path now, not so much the functionality side. So would request that you seriously consider attending. We have a limited amount of space, so we only have about 20 attendees per session. We'll get invites out to you, and we'll make sure that goes out to everyone in Europe. Please register as quickly as you can when you get that, so that we can make sure that you get you get on a seat in that workshop. Other than that, I'd like to say a massive thank you to everyone who has attended. It's been a long session, and we hope that it's been of value. And with extra special thanks to Jerry and Phil, who have done an outstanding job in being very clear, concise, and really explaining to all of us the value that Creo 4 is going to be able to bring. So with that, I think, unless there's any other questions, we will close. Thank you.